Good afternoon, everyone. Okay, first off, who here watches Korean dramas or Korean series? So I may not be able to see your answers. Okay, so I hope I would just assume that more than 50% here are watching Korean dramas or series, maybe through downloads or through Netflix or whatever platform you may have. Okay, so I recently finished watching this new Korean series from Netflix, and it's called Startup. Forgive me, but there will be some spoilers in this talk. So, for those who haven't watched it yet, and if you don't want to hear some spoilers, you can mute me for around 1 minute. Okay. So let me get straight to the core of the series. Aside from the romance that we can draw out from the series, the core of the story would actually be about the startup business that the protagonist started and how it grew up to a really good technology solutions company. Okay, so what are startups first? A startup is a young company founded by one or more entrepreneurs to develop a unique product or service and bring it to the market. So more often than not, startups are about innovative solutions or technology. I think NEC actually houses some startups there. Particularly in the series Startup, they developed an app called Noongill. So Noongill is a mobile application created uh, uh, to aid the visually impaired. So the app focused on using AI or artificial intelligence technology to recognize objects and tell the user or the owner of the phone what the object is or are. So if one user is visually impaired, she just needs to point the smartphone with the app installed, and then the app will tell you what the object is. So that way, for instance, a visually impaired customer will be able to recognize that there are, let's say, three people in front of him or her, or there are actually 30 pesos in the table. Okay. And let me just show you how it works in the series. So in this scene, we see grandma here, who is supposed to be a visually impaired senior. No, this is a spoiler. Used her smartphone and asked the app, "What do you see now?" And then the app answered this. A man and a woman who seem to be a couple are standing on a beautiful beach. Okay, so the application from the mobile phone actually recognized that scene. This is one of the vast applications of analytics. Well, in that sense, an advanced form of analytics. What then is analytics? So, analytics is the utilization of organizational and external data to provide timely, accurate, high value, actionable decisions. You'll have to take note that the key terms here are data and then decisions. This means that analytics should aid us in decision making. Decision making in terms of improving our business operations, our sales, or getting the edge out of our competitors, among other applications. And analytics is also an entire discipline that encompasses technology, work processes, human and organizational factors. And take note, it is not just a product, not just a tool, not a project or a collection of reports, visualizations, or dashboards. Analytics is more than that. Analytics also has its own generic framework. Of course, it can be tweaked depending on the technology setup of an organization or of a company. So the analytics framework starts always with your source systems or data sources. Here, data sources or data can either be structured, unstructured, or semi-structured. Now, to define the first two, the quick definition would be structured data has predefined format, while unstructured data, of course, lacks structure, lacks format, and is usually complicated to process, and of course, to create a format easier to process later on. So the usual examples would be text data, document data, images, sound, and videos for your unstructured format or unstructured data. While for structured data, if you see your data in table form or in spreadsheets form, more often than not, those are structured data. Okay, but there are some cases that you might need to pre-process that for your methods later on to apply to it. And then next in our analytics framework is our data integration layer, where another software takes care of integrating or merging of data, which should be a lot easier to process, which makes it a lot easier to process later on. So we need the integration layer so that we can merge all our different types of sources, of data sources. And then we have the data storage. Data storage comes in different types and technologies. You have relational databases, data warehouses, NoSQL or NoSQL, data lakes, and others. And of course, finally, you have the applications where you can implement your analytics tools on the data that you have gathered, integrated, and stored. Here, you have these three types. You have the descriptive analytics, which others actually augments with the diagnostic analytics. And then the second and third would be your predictive and prescriptive analytics. Okay, so the first one is descriptive analytics, or we also call it exploratory data analysis, or EDA. Usually, this type of analytics draws out descriptive statistics, mainly descriptive statistics, to tell an analyst what has happened and maybe why it has happened, or essentially what is also happening right now. Others also call it reporting because it just reports what happened. Okay, and usually visualizations and data storytelling can also be considered under this type of analytics. And then the second one is predictive analytics, which is usually linked to data mining or machine learning. If you have heard of the terms, the core concept of this type is to tell the analyst what is likely to happen. What is being done here is first, we generate a predictive model through learning from historical data and then use that model to predict future cases. So essentially, we need a model and then we use that model to predict what we want, what variable of interest we want. Okay. And then the last frontier is prescriptive analytics. So the usual tools here would be your optimization tools and simulation tools. So if you've heard of OR, operations research, or discrete event simulation models, those tools are under this type of analytics. These tools tell us what might have happened and telling us what should be the best solution. This is also considered as the most complicated type of analytics. So let me explain by using a simple example. And with that, let me formally define just one type of analytics, how predictive analytics works. We will not be delving into the other types of analytics. So predictive analytics seeks to find patterns and trends from historical data to provide future predictions. So again, you need to have historical data before we can actually provide predictions or before we can actually predict. So one of its tools, again, there are types of analytics, and then under each type, you also have a lot of tools under those types. So one of its types is called classification. So classification performs the task of predicting the value of a categorical data by building a model based on one or more properties of your data set. So it depends entirely on the data set that you have. Okay, so to put it simply, you might want to predict if are you going to pass the subject or are you going to fail it? If a tumor is a malignant or a benign tumor, or if a potential customer will subscribe or not. Okay, so now the model must be based on historical data and the learning algorithms will be capturing these classes. So the classes would be pass or fail, malignant or benign, subscribe or not, based on the properties of your data set. Okay, again, of your historical data set. So in the simplest manner, the classification model will first have to learn rules from the historical training data. We call it training data because this is where our machine learning algorithms or data mining algorithms will learn rules in prediction from. Okay. And then a working model will be generated based on those rules. And then we test the working model on the test data and see if it performs well. And if it performs well, then we have deployment here. Okay, so we now use the model to predict future cases, meaning it's already in its utilization phase. Okay, so let's go back to Noon Guild, the fictitious app from the series Startup. So how do you think the app learned to identify the objects it sees. Okay, so essentially, the app uses a predictive model and it learned from lots and lots of training data composed of many images and many videos. That's it. Okay, as simple as that. But of course, the training data acquisition, the learning part of the algorithm, and the setting up of the model are actually the hardest steps in machine learning or in predictive analytics. Okay, so it really takes time to build those models. Okay, and let's move on to another example. Here I have a sample data set called tax data set. So it's sometimes called a cheat data set. So first off, we have the training data where we have 10 people here having the following attributes: refund, marital status, taxable income, and then the column cheat. So when you say cheat, this is our class label or class variables. This means that if the person evaded tax payments or not. So if it's a yes, then the person actually tax evaded in the past. If it's a no, then the person did not tax evade. Okay. So the next part of this process would be learning the rules from the training data that we have. So we learn the rules and then we'll have the model. We have the produced model here. Okay. And then we test our model on a test data where the class cheat column. So that's why you have here question marks are unknown. So the task should be predicting if the person will tax evade or not. So these are future cases. So at this point, you'll be trying to predict if one person is going to tax evade or not. So I hope at this point this is clear and that you have a pretty good idea of how predictive analytics works. But that's just one of the tools that we have in analytics. Okay. And here are the tools that we usually use in analytics. You have R and Python programming languages. You have Pandas, Tableau, and ggplot for data manipulation and visualization. Some machine learning tools, scikit-learn, Weka, and then TensorFlow. And then storage platforms, you have your MongoDB and then PostgreSQL. And of course, the most important tool out there for everyone, it would be your MS Excel. Okay. Now let me go to the new normal and let's see how analytics performs in the new normal. So, what is the new normal? Simply speaking, it's the way we live now that is significantly different from before. So, the pandemic may exist for a very long time despite having vaccines available already. So, in that sense, the new normal would also stay for a long time, at least not in the next few months. So, the new normal is just a new way of living and a new way of going about our lives, our work, and of course, how we interact with other people. What does this mean? Of course, we'll still be using face masks and then face shields. Not to mention, what do we do with all those wastes? We practice social distancing. We have also reduced celebrations and then less sports. We also have remote learning and remote education. And of course, work from home arrangements. Oh, and yes, we've become victims of 11/11 and 12/12 sale, or should I say more and more deliveries. But seriously speaking, the new normal have significantly increased the number of deliveries of food and other important items. So, what about analytics in the new normal? To be honest, this topic is really vast. So, I'm cutting it to the applications closest to us, at least in my experience in the past few months. Okay, so let me start off again by a timeline that situates how the pandemic was observed in the Philippines. And then later on, I'll be superimposing some analytics applications into the timeline. Okay, so in this timeline, it's not really exact in terms of the time period, so please forgive me on that. So the first confirmed case in the Philippines was actually last January 30, 2020, and then the ECQ was implemented last March 16, 2020. So at this point, there are a lot actually who have engaged in analytics. First and foremost would be DOH and a lot of other research agencies and organizations started with confirmed cases tracking of data, and is composed also of the active, recovered, and that's data sets. So basically this is just tracking your data. This is also considered analytics. Okay. And the next few months produce studies or predictions on the number of cases given some scenarios like implementing the ECQ. So this just means that we are actually predicting based or we're actually simulating the number of cases based on given scenarios. So one of the questions would be what would happen to the number of cases given if an ECQ will be implemented or there's no ECQ or if there is a modified community quarantine and others. Okay, so this in terms of predictive analytics and at the same time, somehow it's prescriptive analytics. Then, still in the same months around April and then May, we also observed the emergence of heat maps and other spatial data maps catering to COVID-19. Okay, so we have here an example of mapping out the density of COVID-19 confirmed cases. Okay, so maybe our decision makers will be able to use this or this map will be able to aid them in providing data-driven decisions, especially in our government procedures. And then we also have our improved COVID-19 tracker from the UP Resilience Institute or UPRI. Their website actually provides insightful reports created from COVID-19 data. You may want to check out their website. It's ncov.ph. So there are actually very good reports there coming from the data that they have acquired. and and then some more heat maps in the following months, but this time there have been efforts in tracking the number of PPEs allocated across all the regions in the Philippines. In this sense, we'll be able to decide on which to put in our PPE supplies next. And another one here, but this one tracks the capacity of medical facilities and then hospitals, thereby aiding us in which points or which hospitals can we have more or can we admit more. These are actually applications of analytics using descriptive and predictive analytics, and then some of these actually touch prescriptive analytics. So what now then? I mean, what is the point that I am raising here? In the new normal, data is king. Actually, even before, we should have already considered that. So if data is king, then analytics is its queen. Data is better processed if it's already in digital form. Digitized data in terms of collection and storage is really extremely important. Analytics make use of computers and data must be available for these tools to be used. So what more in this new normal? This should highlight the collection of data in digital form. I've already seen QR codes used for contact tracing, and this limits physical contacts as well as practices social distancing. That way, data is also collected in digital and structured form, easier to process in our analytics tools. So how do we go about it? So we have some opportunities here. Not only on other types of data, but maybe we can assist our workforce in return to the workplace. Maybe we can use data to map out COVID-19 in affected zones to assist return to the workplace, but only if it's really safe. And then we may want to enhance customer experience. We can use data in the new normal to help e-commerce better understand behavioral trends, and then maybe we can change our operations. Remember, in the new normal, business who adapt survive. And then we may want to explore optimization of costs in our own companies or organizations. Maybe we can use data now to minimize costs and eliminate inefficiencies in our operations. So before I end, let me show you some more analytics efforts in the new normal. Here, this is actually a graph from DOH. This is using descriptive analytics, but to be honest, I'm not really a fan of the chart here. There are some inconsistencies with the chart. And then next, this is an application using predictive modeling. This article talked about an AI model that can detect asymptomatic COVID-19 infections through cell phone recorded coughs. So how do you think the model was built? Of course, it's through training. The model learned from tens of thousands of samples of recorded coughs as well as spoken words. The AI model predicted 98.5 percent of coughs to have COVID-19, and which also included 100% of asymptomatic cases. That is a very high prediction accuracy. Okay, and finally, I also did a simple word cloud on the Twitter data I extracted last March. Actually, it's just a 1 minute extraction, so my data set is actually not extensive. And here are the most frequently mentioned terms that I gathered on that certain point in time. Oh, and word clouds are just visualization alternatives to bar charts. So in that sense, you can see here a bar chart. Notice the terms blame, positive, tested, and precedent are mentioned in a lot in that particular extraction. So hopefully we'll be able to engage in more analytics opportunities in the near future, or should I say now, so that we'll be able to contribute to our organizations, institutions, companies, or to our country through the use of analytics in the new normal. For me, I always believe that analytics is a culture. The vision of having analytics as the core of any organization can only be realized at the hands and minds of its workforce and its behavior towards achieving this. The people in an organization must always think of data, data, and data, not only in the workplace, but also in their everyday lives. Only in this way we can improve our analytics capacity, not only in the new normal, but also in the near future. My name is Raymond FRETH A. LAGRIA. Thank you for watching.